All right, welcome to the second part of our lesson on 3.2, which is functions and relations. We're going to start off by finding the domain and range for each relation given. We're going to designate that domain as our x values and range as our y values. I have my x values listed, and just to help us, I'm going to create an x and y table for our values here. And when I look at it, I have the coordinates, the ordered paired 1, 3, 2, 7, 3, negative 5, and 5, 6. What I'm first going to do is designate my minimum and maximum values for my x values. My minimum x is 1, and my maximum value for x is 5. And that's how I'm going to start my domain, taking my minimum value, making it less than or equal to x, and x is going to be, of course, less than or equal to my maximum x value. So my domain is between 1 and 5, including both 1 and 5. I'm going to do the same for my range now, and I'm going to find my minimum value between 3, 7, negative 5, and 6. Negative 5 is my minimum value, and between 3, 7, negative 5, and 6, my maximum value is 7. Now I'm ready to create my domain and range. Or my range, I should say. My range is going to be from the minimum value of negative 5 to less than or equal to x, which is less than or equal to 7. And that is my domain and range for this first function, or relation. I'm going to do the same here for the next set here. Again, I start off by doing an xy table. That kind of helps. I have the coordinates 0.5, negative 0.5, and 2.3. I have negative 1.4 and negative 6.7, 5.8 and 9.4. I'm going to identify my min and max for my domain. Well, my minimum value is negative 1.4. I'm going to make that less than or equal to x because that's my smallest value in that domain. My largest value is 5.8, so x will be always less than or equal to 5.8, and that is my domain. We know that both negative 1.4 and 5.8 are included because they're actually given as points, and I forgot to put my less than or equal to there. For my range, I'll now look at my y values. My minimum value is negative 6.7. So I start off with that, negative 6.7. Since it's my minimum, that's less than or equal to my y, any of the other y values. And then my maximum value is 9.4. So y will be less than or equal to 9.4. And that is my domain and range for the ordered pairs for this relation here in example 2. Now we're going to do this from a graph to determine our domain and range. It's very important to notice that, first of all, this is discrete. And because it's discrete, we know that because the points are not connected. We also can note that the circles here and here are closed, which means they're included. Okay? I'm going to erase that because it's going to get in the way. And one way we can determine our domain and range is by building walls for our domain and building, so these domains will have walls, and our ranges will have ceilings or floors and ceilings. For our walls, we'll draw walls. Walls are up and down. And we're going to start that from left to right. I don't see any points to the left of this area here, and I don't see any points to the right of 5. This is a wall, this is a wall, this is my min, and this is my max. I can kind of shade this area out here because there is nothing out there for this function. The walls occur at 2 and 5. My floors and ceilings occur, my floor occurs at the lowest point. Floors are a min, while ceilings typically are a max. My floor's minimum, the floor occurs at a minimum, there's nothing below the floor, and there's nothing above the ceiling. My floor occurs at 4, and my ceiling occurs at 9. If this was continuous, I could write an inequality. But since it's discrete domain and ranges list x and y values from max and min. Or from min and max, sorry. From min and max. Okay. So my domain then is going to have this curved bracket. It's going to start at 2. It's going to end at 5. My min and my max. And in between, I have the points 2, 3, 4, and 5. And that would be my domain. And again, that's because I'm working with a discrete function. For my ranges, or for my range, I should say, in the brackets, my minimum value is 4. My maximum value is 9. Guess I don't need that comma there. And the y values in between are 6, 7, and then 9. And so when we have a discrete function, we want to designate very clearly that our domain, the only inputs are valid are 2, 3, 4, and 5. And thus the only outputs we can get are 4, 6, 7, and 9. It's not continuous. There's nothing between 2 and 3, 3 and 4, or 4 and 5 in inputs. And I have no outputs between 4 and 6, between 6 and 7, and between 7 and 9. This is an important distinction to make. Now we're going to determine our domain and range from a data table. We have gallons of gas and distance. This is an input. Thus, this whole side deals with our domain. Our distance is an output, and thus is our range. Now, as an aside, gallons of gas, I should be able to put in a gallon of gas as a continuous amount. There is nothing stopping me from putting in a small fraction of gallons of gas between 10 and 20. Likewise, I can travel mileage between 150 and 300 miles, and I can travel incrementally small amounts of miles there. So this will be, we're going to assume that this is continuous. Again, continuous doesn't mean I stop. It just means that there are values in between 150 and 240 that I could theoretically travel. There are gallons of gas I could put in my car or consume in my car between 10 and 16. In fact, there's an infinitesimal number, infinite number of amount of values of gasoline between 10 and 16. They're infinitesimally small, but they are there. And so this is continuous. So what do we need to do? For our domain, we need to find our minimum value, which is 10. We need to look at the maximum value of the number of the gallons of gas, which is 20. And we can write an inequality for our domain. And our inequality is that x can be anywhere in between 10 and 20. And it can also be 10 and 20. So 10 is always going to be either less than or equal to x, and x is always going to be less than or equal to 20. I can also write this in interval notation, and I'm going to use brackets, which indicate closed circles, or values included. Okay? And I'm going to start with my minimum, which is 10, comma, maximum, which here is 20, and I close with a closed bracket. I can now do my range. In order to do my range, I'm going to find my minimum value, which is 150. I can write that in. My y value is going to be between that and my maximum value of 300. Again, y can be anywhere between 150 and 300, including 300. So 150 is always going to be less or equal to y, which is less than or equal to my maximum of 300. Okay. Again, I can do interval notation. 150 is my minimum. 300 is my maximum. And I use the brackets here to show that both 150 and 300 are included. In fact, when you have these signs right here, you're going to use brackets. Okay? So when you have these signs here, you will use brackets. Again, we can also do domain and range from a mapping situation. We could consider this both from the continuous or the discrete perspective. If we were to consider this from the continuous perspective, this would be my min, and my h here is going to be my input, and thus my domain. So my minimum is 7. My maximum is 12, so I know that x is somewhere between and including 7 and 12. My height here is going to be my output, thus my range. And I can say my range has a minimum of 41, which is less than or equal to my y value, which is less than or equal to my max, which is 59. And that's assuming continuous. If I were to assume discrete, my domain would have the brackets, and I would include every value for my domain, which would be 7, 8, 9, 10, 10, 11, and 12. I don't know if I really need to put the 10 twice there. On my range, it would be my y value starting with 41, 45, 49, 52, 53, 55, and 59. And those would be my range. So my domains would only have those inputs, and my range would only have those outputs. And this covers both, assuming this is continuous or discrete. Given that we're dealing with ages and height, I think we'd be looking more at a continuous situation. This is a good stopping part for part 1 of day 2 of lesson 3.2. Please watch the second video, part 2 of 3.2, day 2.